Thank you so much. Thank you all for coming on a sunny Sunday to hear me talk on the history of data visualization. Let me start by introducing myself. I wear two hats, and they're both represented on my license plate. And the license plate of Ontario has the motto underneath, yours to discover. So data viz, yours to discover. My primary work is as a developer of graphical methods for complex data, particularly categorical data and multivariate data. I develop things like the mosaic display and other kinds of graphical methods designed to help people understand complicated data such as we see in the world today. But I also have a great passion for the history of data visualization. I should say I'm an amateur historian, not a professional one. So my work here has been involved with trying to catalog and document and make sense of things about the history of data visualization that we should be interested in today and that should drive the kind of work and problems that people consider. So my plan for today, I want to try to provide a wider context for the things that I'll talk about. I'll give you a guided tour of the history of data visualization. I'll focus mainly on a particular project I call the Milestones Project, designed to document a lot of this information. And my main focus will be a period of time towards the end, the latter half of the 1800s, that I call the golden age of statistical graphics. So my co-author on my new book would chide me if I did not begin with a shameless plug for our new book called A Gleam in the Mind's Eye. This is a study of the rise of visualization and visual thinking. The image on the screen is a remarkable graph by William Playfair, who's considered one of the originators of most of the modern methods of graphical data analysis today. He's taking a long view of history. He's trying to show the entire history of civilizations between 1500 BC and 1800 AD. Why did civilizations arise? Why did they fall? This was the kind of question that he was trying to answer. So I'll begin with some remarks about the state of data visualization today. We're immersed in a sea of data, from fitness trackers to election polls to economic indicators. Data is all around us, and these relate to questions of personal interest and of societal interest. So how can data visualization help? Complex data can be made crystal clear and shown to the briefest glimpse of the eye with well-designed graphs. And here is a graph developed by the Wall Street Journal showing the impact of vaccination for measles in the US from 1920 up to sometime after 2000. The coloring of the squares shows the intensity of number of cases of measles, and you can see at a glance that after the introduction of measles vaccination, this is in the US, measles dropped by a factor of 10. Powerful graphs have the function of being able to allow you to make comparisons easily. In 2014, due to fear about the effects of vaccinations, vaccination actually dropped off in many areas of the US, and in precisely those areas, measles cases began to rise again. And so we can say that effective graphs can cure ignorance, but they can't cure stupidity. Here's another graphic. The purpose of statistical analysis is often to make complex comparisons crystal clear. Here is a graph showing gun homicides in Western democracies in relationship to GDP per capita. You can see that the US at the top stands out clearly as a clear outlier. All the other countries are down below 5. The conclusion here is inescapable. But of course, causes are arguable, and we always want to know compared to what. I'd like to try to put visualization, graphs, images in a somewhat wider context. We can think of all forms of communication as composed of some amount of words, some amount of numbers, and some amount of pictures. So we could think of maybe poetry as involving 60% words, but 40% pictures, whereas a table is mostly numeric. This allows us to think about aspects of how the image relates to other forms of communication. But there's another dimension as well, and that is beauty, aesthetic appeal. So in the history of literature and art, there are some things that are so strikingly powerful that they sort of knock your socks off. Other examples are sort of not so great. They, meh, you don't feel any impact from them. Let me begin with some orienting questions. So, when did visualization actually arise in human civilization? When and what purpose did it serve? In the same way, we can ask about the visual depiction of numbers, of data. When did that arise? But more importantly, why and what purpose it served? So let me make this a little bit more concrete. Let me ask, when were there examples of discoveries in the history of science that you might argue would not have been achieved otherwise except for a graphic representation? Well, it turns out that there are quite a few examples, and I'll just mention a few. John Snow's discovery of the source of cholera in the London outbreak was based on a dot plot where he plotted the number of cases and showed that they arose around a particular pump, the Broad Street pump. I'll talk later about Galton's discovery of weather patterns in Europe. Another example is what's called the butterfly diagram by Maunder, that he plotted the occurrence of sunspots and noticed that there was a clear 11-year cycle that was then later explained. And then finally, the Hertzsprung-Russell diagram in stellar astrophysics was a plot from which physicists realized that stars in the sky exist in different categories, different temperature classes, and this provided theoretical insight into the development of stars. So let me go back to the beginning of time, 2,000 years ago, 20,000 years ago, sorry. The first visualizations could arguably be best illustrated by some paintings found on the walls of the Lascaux caves in Montignac in the Périgord in France. They are astoundingly beautiful. The first archaeologist who saw them called them the Sistine Chapel of prehistoric art. But why? Why? What was the reason? What were they thinking? Why did this early group of Cro-Magnon men decorate the caves with these images? Well, One view might be, oh, maybe this was designed to celebrate hunting success or to indicate wish for a successful harvest. But these were paintings of bulls and horses, and they did not hunt bulls and horses. Rather, they hunted reindeer, and there were no images of reindeer in these caves. So you can say that this was a symbolic purpose. We don't know exactly what it is, but there was some, maybe a higher deity that they were appealing to, some representation that they wanted to last for their culture. But more importantly, this could be said to be a cognitive revolution that took place between Neanderthal man and Cro-Magnon man, where the idea of a visual image suddenly arose, and it served the purpose of the development of culture at the time. The next development in development of graphics were early maps and diagrams. And this is one of the remarkable images found from 2000 BC on a tomb in Egypt. It's a depiction of a wrestling match, but it's more than that. It's like a modern-day graphic novel. It shows a sequence of moves of two wrestlers, each one trying to throw the other. Again, we might ask why. What purpose did it serve? Again, we don't know, but the person whose tomb it was, perhaps he was a wrestler as a youth, and then maybe later a coach, and one can think of this graphic image on his tomb as his final lesson. So now on to the Milestones Project. This is something I began about 20 years ago. As I mentioned at the beginning, I work in the development of new novel graphic methods. And like so many people in this area, we think, oh, we've created some new fancy graphical method, and it's brand new. No one has ever thought of this before. But in fact, almost all of the representations that are currently used have earlier precursors, and it's important to understand this history. So the Milestones Project appears as a website. It's an interactive timeline. There is a calendar giving daily events. In fact, I just started something on Twitter. Today in the history of data visualization. As I looked through this material, it became clear to me that the roots of all the methods of graphical representation we use today weave in and out of a number of different traditions or themes, cartography, wayfinding, making maps, data. When did data arise? When did data become prevalent so that it could be used for planning, for policy, for making decisions? Visual thinking also arose in a period largely in the 1800s, became widespread. Technology, the invention of printing, and then later of lithography, allowing color printing, made an enormous impact on the production of graphical works. So let me give you a bit of a content overview of some representative graphs from the Milestones Project. I won't say much about them individually now, but for every single graph, one can ask, why was it made? What was the communication goal? What makes it suitable for being called a milestone in the history of data visualization? How does it relate to other developments that came earlier or later? In parsing the history, it became clear that one could define the period of time into epochs, each of which had a recognizable theme. And I'll give a few examples of some of these. We can also visualize history in a way if we have a database of historical important milestones items. Where did they occur and when? We can see the blue curve. Most of the developments in my milestones database arose in Europe up to around the 1900s, when, after the 1900s, development of graphical ideas or ideas for representing quantitative information took off in North America. So on to the 17th century, the earliest seeds of data visualization arose in connection with maps and diagrams. Here's the first world map by Axiomander, a mechanical diagram by Raymond Lull, designed to answer philosophical questions. Each of those little wheels could be turned, and it would give an answer to one of Aristotle's philosophical questions. The development of the idea of graphing a theoretical function occurred to Nicholas Oresme, and then Catalan Atlas. So here is this Catalan Atlas, which is a marvelous example of visual storytelling. Eamon Kresge was contracted, if you will, by the King of Majorca and asked to produce new and improved maps of the entire known world at the time. But it's more than that, just a map. These are like route diagrams. They tell you what you'll see if you take various pathways. So there were a map of the Western world, of the Eastern world, perpetual calendar, lunar tables, and so forth. Moving on to the 1600s, this is a period that I characterize as, it was the birth of the scientific revolution. The important questions of the day concern measurement and theory. Newton had developed the idea of the universal laws of gravity. Analytic geometry arose. Theories of errors of measurement and fallible data also arose during this time. We have the birth of the initial ideas of probability theory that eventually led to statistical methods. Here's one example from Christoph Scheiner. Galileo built one of the first telescopes in 1610. Shortly thereafter, he discovered an amazing variety of new phenomena: the moons of Jupiter, Saturn's rings, sunspots on the moon. And Christoph Scheiner designed this graphical representation, recording positions of sunspots on the sun over a period of 1 month. It's an excellent example of what you would call an A+ for visual design today. Unfortunately, he had the wrong theory. He thought the sunspots were satellites around the moon as opposed to some other phenomenon. This is what I believe to be the first graph of statistical data ever produced. It was done by Michael Florent van Landgren, an astronomer to the Spanish court. It's Flemish. It shows the determinations of the longitude distance between Toledo and Rome by all the known astronomers: Mercator, Tycho Brahe, Claudius Ptolemy. And what's remarkable about this is the idea of making a graph of data did not exist. He could have shown that information in a table. He could have sorted it by row, by date, or by provenance and so forth. But he chose to make a graph. Why? because what he wanted to show principally was that the range of all these estimates of this distance between Toledo and Rome was enormous. That is, enormous amounts of error occurred, and therefore the problem of longitude really needed to be solved. He gave as his best estimate the center. The actual distance, though, turned out to be smaller than the smallest observation in the data. Moving on to the 1700s, the 18th century witnessed the initial development of a wide variety of new graphic forms for mapping things that were presently invisible. How do you map the deviation of the compass, or wind directions and wind speed across the Atlantic Ocean, for example? There were a variety of new applications of graphic methods in this period. This is a graph of representation of history from Joseph Priestley. Now, Priestley was best known as the inventor or the discoverer of oxygen, and he also invented soda water. So every time you think of ordering a Perrier, think of Joseph Priestley. But this is an attempt to show the history of the world from 900 BC to 1750 in a way that shows the dominance of culture, the extent of the range of cultures. He actually made this as a gift to Benjamin Franklin, with whom he had a correspondence. The 1800s, the beginning of the 1800s, saw what I'll call later an avalanche of data, new data on new topics, on crime, on disease, and so forth, was being collected. We have new graphical methods used in inventive ways in cartography, invention of new graphical forms. It was primarily an age of enthusiasm for graphics. So this is one graph by William Playfair. It's an attempt to show 3 time series all together. He's showing the price of wheat by these bars, and the wages of a good mechanic over time. And in relationship, he's showing the rulers of the United Kingdom. He's trying to tell a story. He's trying to say that at no time in the past were workers better off than they are today. That is, the rate of wages in relationship to the price of wheat was much greater. Is that something you see, obviously? I wouldn't think so. In fact, a much better graph to show this data would have been a scatter plot of the ratio of wheat to the price to labor, or a scatter plot of one against the other. But the scatter plot had not been invented yet. Playfair's thinking, his visual thinking, was only of making time series and trying to relate them through a verbal argument. We move on to my favorite period in this history, what I call the Golden Age. This was a period of not only new innovation, but the most incredible beauty of graphs ever produced. A wide variety of new graphic forms were used, and I'll focus largely on this period. I think I'll skip this slide. And now I'd like to tell some short stories related to themes in the history of data visualization stemming from the Golden Age. So I'll talk about the rise of modern social science under the hands of André Michel Guéry, graphic vision, Charles Joseph Menard, visual discoveries by Francis Galton, and then finally the statistical albums that have become some of my favorite sources. So what were the big questions of the early 1800s? This was the rise of globalization. This was the beginning of the present forms of European states. Data was important for collecting taxes or raising an army or other sorts of things. We also have the beginning of measurement of human characteristics and the beginnings of statistical theory, the idea of the normal distribution, as applying to human characteristics. You could line everybody up and order them by height and get a lovely bell-shaped curve. This was a time of collection, of widespread collection of data by particularly France and English official state actors. The clearest example is the Ministry of Justice in France that in 1825 began to collect data on crime in every single department of France, recorded every person accused, their age, sex, time of day, what the crime was, and so forth, all fed to the Ministry of Justice in Paris. Other forms of data was collected, but finally now, social issues could first be addressed with data. So André Michel Gary was a young lawyer. His first job, in fact, his only job, was with the Ministry of Justice, and he quickly fell into the role of being the tabulator of this data. His work in 1832 can be considered the launching pad of modern social science, of criminology, of sociology. I'm going to skip a little bit. At the time, this was the time after Napoleon's defeat, there was widespread unemployment and chaos in France. Many people moved to the big cities, particularly Paris. Crime became a great concern. And then, as now, there were two main points of view about how you can deal with crime. The liberal philanthrop view said, well, give people more education. Give them better schools, give them more religious instruction. The conservative view said, no, build more prisons, make things harder to avoid recidivism in crime. Gary began with tables. He tabulated the rates of crime by sex, by age of the accused, by the type of crime, by season. And he noticed something absolutely remarkable. They remained more or less constant over time. That is, an invariance was shown over time, and yet they varied widely between the categories that they were broken down to: age, sex, and so forth. In any given city, you saw the same rates of crime occurring year after year. And so he asked, well, does this data reflect personal individual behavior? Or does it represent something much wider, something that we could call a social law? He said, we're forced to recognize that the facts of the moral order are subject, like those of the physical order, to invariable laws. This was the initial idea that social behavior could be studied as something that involved lawful behavior. So he made a variety of maps showing the distribution of various variables. Here he's showing in a single view rates of personal crime, property crime, and education, with a view to asking, are either of these related to education, either type of crime? Well, no, not really. In fact, there seems to be no relationship between the areas that are dark are always the worst in each graph. This was a brilliant comparative graph. I'm going to skip on a bit to my next story that concerns Charles Joseph Menard, another of my great heroes. Does anyone recognize this figure? It's a representation of the terrible fate of Napoleon's army on the 1812 campaign to Moscow, starting off at nearly 500,000 strong, decreasing, and then coming on the retreat back with a mere 10,000 men. E.J. Marey said that this was a graph that defied the pen of the historian, and Tufte later called it the best statistical graphic ever produced. So why? Well, this is an example of visual thinking by Menard. He was primarily an engineer working for the ENPC in France. He was sent to investigate the collapse of a bridge across the Rhone. His entire report was just that image. Why did the bridge collapse? Well, the supports washed away along one side. I'm going to go on to another example of visual explanation. He looked at the trade in cotton between Europe and the rest of the world before the US Civil War and after the Civil War. Blue going to the North America. Most of the cotton imported to British and French mills came from the United States. After the Civil War, that went down to a trickle, and the cotton was then imported from India. Another example of visual explanation. I'm going to skip a bit here and talk about Francis Galton's greatest discovery ever, perhaps one of the best examples of visually based discovery. He started a program to ask all the weather stations in Europe to report every single day, morning, noon, and evening, temperature, wind speed, direction, barometer, and so forth. And he made, for 3 times a day, for 31 days of a month, these little iconic maps. But how could he see patterns? How could he discover what was going on here? Well, his next step was to do an abstraction to make small little iconic symbols to represent each of these regions. And then he went on to ask what varies with what over time and space. So he's showing pressure on a schematic map, wind direction, temperature, and this is for one day of the month of December. Putting those all together, he sees a pattern here. He sees that in the first half of the month of December, most of the temperature is shaded black here, whereas in the second half of December, most is shaded red, and he realizes that this corresponds to low barometric pressure corresponding to wind directions in the counterclockwise direction, whereas high barometric pressure results in the opposite direction. From this came a theory that explained how weather worked. It was later explained by something called Dove's Law. And shortly thereafter, this theoretical insight of weather patterns was turned into practice. We have the first weather map, first modern weather map, appearing shortly thereafter. My friend Howard Weiner said Galton did for weathermen what Kepler did for Tycho Brahe. So maybe paraphrasing Bob Dylan, maybe you do need a weatherman to know which way the wind is blowing. Do I still have a couple minutes? Okay. I'm going to go on to talk about the pinnacle of this golden age, the statistical albums produced in France, Britain, Germany, and elsewhere. But the most remarkable ones was a series produced under Émile Chesson in France, 18 volumes with most incredible examples of the wide range of all known graphic forms produced at that time. Here is a lovely example of spiral time series on a map. I'm not quite sure what I would make of it. That is, where population was greater than average, where it was less than average, but it's a rather beautiful diagram. This is the graph that launched my interest in the history of data visualization. I worked for about 10 years developing what I call mosaic displays for showing categorical data. Here is an example of what is actually a recursive map of France showing the distribution of passengers and goods from the 4 terminals, the 4 railway stations in Paris, out to the rest of France. From Paris, things go out to Gare du Nord, and to each place, those passengers and goods are broken down and then they're distributed further. Another branch, the Gare de Lyon, goes down to Lyon and the south. It was something that when I first saw it, I nearly fell off my chair. It was so remarkable that something like this had been done and so long ago. I'm going to skip a bit, and I just want to indicate that all these graphical works, the album de Statistiques graphiques, are now available on David Rumsey's incredible website. If you Google David Rumsey, Chesson is the author, you'll find this marvelous collection of visual eye candy. So, what are the lessons of history for the future? The first one is we should focus on phenomena, not numbers. All the examples that I talked about were cases where there were some important questions about disease, about crime, about trade. Visual representation today should focus on the questions. The second lesson concerns graphical insight. John Tukey talked about the interocular traumatic effect. A good graph should hit you between the eyes. Impact means interocularity, it means immediacy, and it should have some view of inescapability. All of my heroes talked about letting the data speak to the eyes, speaking directly to the eyes. Second lesson is that graphical methods today should strive for that. I'm forced to skip this and go on to my last lesson. I work in software. I use R software for developing new graphical methods. And I've been struck by the difference between menu-based systems and code-based systems. But even more than that, I've worked in a variety of different computer languages. And there is something about a computer language that makes it easier or harder to express the idea for a new graphical method. For the future, designers, developers should try to reduce the distance between having the idea in your head and being able to write down code, because we don't do pen and ink much anymore, and produce an interesting, impactful graphical display. So, thank you very much for your attention.
So we'll open it up to questions now, and we have some mics circulating.
Thank you very much. I'm with the, is on? Yeah. I'm with the Center for Spatial Data Science at UC Chicago, and we appreciate your help with the Gary data set. It's now in our software.
Great.
So one of the questions we run into is that with a lot of data viz, there's a confirmation of the expected and not as much discovery of the unexpected. So you confirm things you already know, correlations of poverty and poor health or something like that. And so from these historic lessons, what would you say, how do you have to set this up? What's the research design behind it to really facilitate the discovery of new insights?
I think the example from Galton, although I didn't have time to go through it in as much detail as I would like, is the best representation of that. What he shows in this wonderful book that the images came from my good friend Steve Stigler, is he showed the series of steps he went through, first constructing these large-scale maps with these little stamps showing all these variables, thinking about them. What varies with what? Then trying to abstract the information into a display that was more coherent, that showed less of the noise and more of the signal. Squeezing the signal out of data is the hard part, and that's what takes a lot of thought. And you're right, many of the examples of present-day graphs, they sort of confirm what people were already thinking. But if they do that well, and if they show it in an insightful, impactful way, that is certainly a plus. Discovery is hard work. I mean, it takes brains, but more than brains, it takes a lot of deep thought about the problem.
Hi, thanks very much. So I've been a fan of data visualization and infographics for a long time as an amateur. But one of the things that has struck me over the years, especially in recent years, the last, say, 15, 20 years, is the sort of rise of the kind of quick infographic, and how often when you really look at them, they're actually kind of lies.
Right.
Where there's like
Right.
50% of the people who do something,
Right.
and then it turns out it's 2 people.
USA Today graphs. Right. Or the Sunday New York Times Magazine every week does a poll of people. And it's, what do you think about gun violence, or what do you think about this, and agree, disagree, or don't know. And they show it as not even a pie chart, but they show it as a fanciful thing of, it's, if it's gun violence, a gun that's divided into the sections of. I mean, this is not my taste. Some people like it, but I think that these are not useful kinds of graphs. Yet in graphic design, in the area of graphic design, there are a number of people who are doing incredibly interesting stuff. Manuel Lima, who was here earlier, Alberto Cairo, and other data journalists are now have the tools, the code, the ideas, and to produce interactive graphics. My wife sent me something from the New York Times showing the trend across the US midterm elections by which, in each district, whether the district moved to the left or to the right. And it was a beautifully done explanation combining text and an interactive graph. So I look to data journalists for best exemplars today.
Yeah. Hi. I wanted to, great presentation. I wanted to ask you if you could comment on kind of the state of the art in projecting the future, data that doesn't yet exist, and graphing that.
Whoa. I'm not sure I can get my head around that, projecting the data that does not exist. Well, I went to a talk by Mimi Onuhu yesterday. She talked about data that does not exist and why it does not exist. These are interesting and powerful questions. We need to have more detailed information about occurrence of crime or gun violence or the state of the economy, and it needs to be made available and accessible. So a number of the initiatives that are taking place today, open data. Every research paper you publish now, you have to make the data available for other people to vet, reanalyze, and so forth. So these are things moving in the direction of the future.
We have a question over here.
Michael, thank you so much. It's been a wonderful presentation, and I was actually really excited to learn where the word statistics came from, because I didn't know that.
Yeah, so numbers of the state.
You're right. Yeah.
Aschenwald.
Yeah. So I was wondering, as an urban planner, there's this emphasis in cities of using dashboards, right? Real-time data and all of that. And so, I have my opinions on it, but I was wondering about yours and what you thought about the practicality, usefulness, the dangers of dashboards.
Dashboards are maybe a useful summary, but they're a packaged summary. They give someone's thoughts about what should be shown and how it should be shown. It doesn't allow people to ask their own questions. I mean, maybe not everyone is interested in asking their own questions, but for people who do, the availability of the data in an accessible way is really important. Together with that, you need tools. You need to make it easy for people to make graphs of the stuff that they're interested, to ask the questions, the visual questions related to the substantive questions. So this is beginning to happen, but it's still a work in progress.
Hi, thank you so much. For sort of an everyday layperson in not-for-profit or for-profit, what would you recommend for us to use these great ideas and not just in a pie chart or something that you can get on Excel?
Probably the easiest way to start is with, there are a number of systems available on the web. Google Spreadsheets is now connected with a whole bunch of graphical tools. They may not be the absolute leading edge, but they're a wide enough assortment that you can begin to do that without investing a great deal of time learning how to write code in R or SAS or, God forbid, SPSS. Google is not unique. There's a Many Eyes project from IBM that creates a collection of tools. People can upload data, and then a variety of different people can look at the same data in different ways. And this is often an important way to learn about what the possibilities are. There's a competition, the Kaggle competition, every year. Teams are given a data set where there is a known outcome. Who survived, who lived, who died on the Titanic? How do you predict that? or explain it from the available data. People submit their code and their results, and then you can look and see, oh, this person tried something really different. I never thought of that. That's a really good use of the social crowdsourced construction of data, graphics, and information visualization.
Yes, you know, statistics was never my forte, so I can't believe I'm asking you a question. NBC News was projecting the election results.
Yes.
And for the first time, as far as I'm aware, I saw an infographic, it was public television rather. They showed an infographic of the Republicans and the Democrats, and I think it was in real time showing how slowly Democrats, but it was a graph, and every time the commentator showed the graph, she had to once again explain what we were looking at, and I found myself getting a little confused and not fully understanding the graph. But you're saying that if the infograph really works, you need not many words, and the graph should simply tell you right away what you're looking at.
If the phenomenon is easily understood with a few words, a graph can replace those words. But more complicated phenomena, maybe not so. I should apologize. Some of my graphs on these slides, I could see were not entirely clear and visible in terms of the size and orientation. If you're interested in following up, the slides are all on my website, dataviz.ca. So I'm not sure that I can, if you show me the graph, I could maybe say something more about it.
So we have time for just one more question. I think I saw a hand in the center.
Hi. So data visualizations, obviously the visualization is a huge component of it, and in your presentation here, traditionally it seems like we're talking about a two-dimensional display. So as we move into new technologies like virtual reality, where you're able to interact, in a more three-dimensional plane with representations of data, do you think that's going to open up a whole new field of data viz, and what impacts have you seen so far already?
In some areas, there is great potential for that. In other areas, it may be more like a toy, something that is kind of fun, but doesn't really necessarily lead to insight. fMRI recordings of brain activities. You have a three-dimensional volume of stuff going on inside your head, and areas light up when you hear a joke or when you feel sad. How do you represent that? How do you explore what's going on? This is an area where 3D, interactive, maybe virtual reality kinds of stuff, where you can wander through someone's brain and see what areas are lighting up in connection with some particular thing that they've just experienced. So there is a lot of potential out there. A lot of the developments that I see are kind of interesting, but I don't know where they're going. But other things, I look at and say, wow, that's something new. I hadn't seen that before. Well, thank you once again for coming out on a Sunday.